In this lecture, we are going to put Newton's second law into practice. We will be looking at dynamic problems, which involve objects that are accelerating because the net force acting on them is not zero. Newton's second law tells us what happens when the net force is not zero. It states that the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Net force equals mass times acceleration as vector. On the other hand, acceleration is net force divided by mass. This gives us the most famous equation in physics, F equals ma. This is the equation for takeoff to get a massive aircraft with mass m to accelerate with acceleration a down a runway. The engines must produce a net force that overcomes drag and friction. More force means more acceleration. More mass means less acceleration for the same force. Take this one for example. Now, if we have a force, the force acting on one block, the acceleration is 2 meters per second square. What's going to happen if we double the force? Keep the mass the same, double the force, fix the mass, acceleration should double. Now, if we keep the force, double the mass, the acceleration should be reduced to half of what we have. Because this one is acceleration should be F over m. This one is 2F over m. This one is F over 2m. The SI unit of force is Newton. 1 Newton of force acting on an object that has a mass of 1 kilogram. It produces an acceleration of 1 meter per second square in the object. From this definition and Newton's second law, we see that the Newton can be expressed in terms of fundamental unit of mass, length, and time. So 1 Newton is 1 kilogram times meter divided by second square. In United States, we also using pound as unit of force. If we rearrange the second law to be A equals force divided by mass, you can see that for the same force, a larger mass results in a smaller acceleration. This is why we say mass is a measure of an object's inertia, its resistance to a change in motion. The sumo wrestler has a lot of mass and therefore a lot of inertia. The child has very little mass. If they both push on each other with the same force, the child will experience a much larger acceleration. The word inertia comes from the Latin word inerts for idle or lazy. This is a crucial distinction. Mass is amount of stuff in an object and is the same everywhere. Weight is the force of gravity on the mass. Weight equals m times g. G is 9.8 meter per second squared, acceleration due to gravity, and it changes depending on where you are. On the moon, your mass would be the same, but your weight would be about only 1/6 of what it is on Earth. It looks like Newton's first law is a special case of Newton's second law when the net force is zero. But the important point, Newton's laws only hold true in what we call an inertial frame of reference, a frame that is not accelerating. For most of our purposes, the Earth is a good enough inertial frame. But if you are in an aircraft that is banking, climbing, or accelerating, your frame is accelerating, and things get more complicated.